Okay, so let's just look at some examples and I'll explain the rules as we go along. So let's start first with log base 7 minus log base 7 of 5. So log base 7 of 3 minus log base 7 of 5. So right away, I noticed that both of the logs have the same base, which is what allows us to do any of this simplifying in the first place. So because they're both log base 7, I know that when these two are subtracting, that it's going to be the big number right here divided by each other. So we'll end up with just one log base 7, right? Because we're working in log base 7. Like imagine you're working like a system and now we're working in log base 7. And in log system, if the two things subtract each other, they're just dividing. So we can take these two big numbers and divide them by each other because when it's subtracting, we're dividing, and when we're adding, we're multiplying. Okay. So let's look at another example real quick. So if we have log 10 minus log 5, and this one, it doesn't say the log, but when it doesn't say the log, we know that that's like log base 10. It's because it's just like the most understandable and easiest log to work in. So it's what you kind of want to get to most of the time. So log base 10 here for both of them. And it's the big number is 10 on this one, and the big number on this one's 5. So we're just going to divide those two numbers by each other. And remember, we're working in log base 10, so we got to write that first. So let's divide the big number by to two big numbers, and then that can simplify because it's 10 over 5. So we're still in log 10, but we can simplify that to 2. So that's that one. And let's look at one where it's like addition, which would be a multiplication. So yeah, we can look at this one real quick. This is a good one. It knocked a few things out. So first off, you see this X and this Y, and I don't know, like it just might be like a little bit like I don't know if it's intimidating more, so it's just like kind of confusing. But those X's and those Y's literally mean nothing here. They're just the same as 10 and 5. They're actually easier because you don't actually have to divide them. You can just, you know what I mean? Like it's just X and Y. So those could be any number. It doesn't really matter. But the point is that those are the big number in this situation. So but like obviously we have log natural, like the natural log here, which is kind of similar to like log with nothing under it. It just means this. Like I don't know why they put this on here, but it means log E, which is just also another log that comes up a lot. And so they rewrite that as the natural log, which is right like ln. But then another thing, and the first thing you should really look at when you look at this one, I should have said this right away, is that there's this 3 out front and this 9 out front. And when we have a log and we're trying to simplify it and we see a number out front, the first thing we should do is fix that. So the way to fix that is by raising this number right here to the power of the number on the outside. So for this one, it's 3, so it'd be x to the third. And then for this one, it's 9, so it would be y to the ninth. And then now we can work with these two just like this one up here. Okay, it's the same business. We're just going to look at these two numbers. We're simplifying it, so it's just one natural log, and we're adding, so it's going to be multiplication. So we're just going to multiply the two things together. Just put them right next to each other. There's like a multiplication sign in there. So that's for um, condensing. Let's look at like expanding real quick because it like requires a little more thought. So if we have like log base 2 of 5x and we want to expand it into like, so if we think about this is the unexpanded form, or sorry, that's the expanded form right here, this one, and this is the condensed form. We have it in the condensed form, so we want to get in the expanded form. So how we do that is we look at this and we say, okay, we have 5 and we have x. We have 5x. How can we split that up into two things like multiplying by each other or dividing by each other? Like what two numbers multiply or divide? So if we found two numbers that multiply to 5x, we'll use plus, and if we found two numbers that divide to 5x, then we'll use minus. But in this situation, it's easiest to just use multiplication, and most of the time you will. So we break up the log 2, into 2 logs. So you have log 2, and we have another log 2. And we know we're going to be multiplying because what two numbers would multiply to 5x? Well, that's just 5 and x. And that's it. Like, it's literally just write log 2 twice, figure out what two numbers either multiply or divide to get you this number right here. And then the last thing, okay, I can do one more actually. Let me see. Or, yeah, let's do that. That's a good one. So log 3, 12x to the 7th. So this one is a little different because we have this exponent. So remember, we want to, let's just say, like, whenever we're doing this expanding, let's just write this first. Like, we have log 3, we have another log 3, and we have some function right here, either plus or minus. And so we want to look at 12x to the 7th. And remember, I said that you first want to deal with that number in the front. So in here, it was 3 and 9. Well, in this situation, we want to deal with the exponent first. So let's bring the exponent out front. So the same way you can take the front number and make it the exponent, you can take the exponent and bring it out front. So you make this 7 log 3 12x. And now that's a lot more manageable. So like, what two numbers multiply together to give us 12x? You could do 12 and x, or you could do like 4x and 3. It doesn't really matter. I don't really know why they have you do this. Like, you'd never do this really, but let's just do, for sake of simplicity, let's just do 12 and x. And then they're multiplying, so this is a plus. And then we still have to worry about this 7 right here. And what you do with that 7 is you just throw it on one of them. It doesn't matter which one. You just have to put it on one of them. Not both, just one. So yeah, that's how you would do it if you had an exponent right here. And like, obviously sometimes you'll have numbers that are like this. And it's like, okay, well, clearly I'm doing division here. And so you would just set this up as like let's just do this real quick. Log 3 12 minus log 3 15. That's really the only time you want to do division, is when they straight up give you a fraction. Okay, so last thing we have to do is this like one rule. It's pretty easy rule. So it's, the way I think about it is, if we have like a number, like let's say log base 5 3, we can split this up like this. So first we start with this and with this. And this is when we're solving for it. So when we want to find a number, like, so we're in log this whole time. Let's say we actually want to find a specific number for that log, like a value. Then this can help with like either a calculator, or like if you're actually doing it yourself, it's really helpful. So you can make these two have any base you want. So usually what base you want to make it is 10. And now this is like the whole like actual part you have to remember, is you take the big number and you put it on top, and you take the little number and you put it on bottom, and it's that simple. So you literally, any number, any log you get right here, you're just going to rewrite it first in this form, log 10 over log 10. And then you're going to put the big number on the top and the little number on the bottom. And that's all you got to do. And it doesn't matter if this big number, let's say it's a fraction, 8 over 17, you just write 8 over 17 over here. So yeah, really simple. I think that covers everything. Sometimes here you can use E as well, which is nice. Like, E is the same, where it's like a super common one, and you can like put that straight into your calculator, and you can just write, like, there's literally a button that's LN, and then you can just write LN 8 over 17, and that'll give you a number, and then you can write LN 5, and then divide those two numbers by each other, and you'll get a constant.